What's up, guys? Welcome to today's video where we are going to be learning about what is data and how you can present it in different ways and forms. If you have never heard of the word graphs, let me tell you what is graphs. It's a visual representation of data. We will come to know what is data, what is graph, and everything in detail. So let's dive into it. Thank goodness there is no number 6, 7. Oh my God. What is data? You've heard of this so many times in so many different places. Data, data, data. What is it? So it's basically values. Something that is a value. It's numbers or facts or observations. Like if you say today it recorded 4 degrees, right? It's a number, it's a data, it's a temperature data. Or if you say I got 98 in my test score, that's again a data. So data is basically the numbers, the facts. Facts in the sense it can be how many people died in COVID-19. So it can be those facts and observations and numbers. All these things is a huge data, right? It can be anything. It can be as simple as your favorite colors, your hobbies, or how many pets everyone in your class has, the temperature, the test scores that I told you about. It can be that small to it can be really, really huge, like the data of Amazon, how many people are purchasing things every single day, or what is the most purchased items, or how many times this one um product was sold. Like if you say a very trendy one was the Labubu. So how many Labubu dolls were sold in the month of December, October, like that. So that's data. Why is it important? Is because it will help you compare things. It will help you answer questions. Like let's talk about the Labubu dolls. These toys um were, you know, they crashed the whole toy market because people were not buying other toys and they were looking for Labubu toys specifically, and they were looking forward to that one specific like limited edition version. Not only kids but adults were buying it, influencers were buying it, right? So this was the entire hype. There was a hype for slimes. There was a hype for stress balls. There was a hype for fidget spinners. So every era you see, there would be one product that would come up and it would be sold very highly. And why is this thing is important is you need to know the data behind these things to actually be able to work with things, right? If you did not know that these many people got Labubus, how would you know that Labubu was favorite for every person? You wouldn't know. You would think that teddy bear was still the perfect thing to gift someone, right? Which would be wrong. In the era of Labubu, if someone gifted you a teddy bear, would you be happy? You, I would be happy. But yeah, that's not the question. The thing is, it's like you would be not updated with the trends. So how do the trends form? Because of data. So it's like everywhere. You have to know what the data is. Now, we know data is so important. We know its numbers. We know how important it is. But do we like data? If um, when you see it in Excel sheets, you will know that data is so ugly in table form. In rows and column form in Excel sheet, it is really ugly. It's like a dirty work to be cleaned and done, right? It's a whole job. Date like they are jobs for data collecting, data entry. Okay, so you collect, there's a job, data collector job. Then you enter the data, that is in data entry job. Then you clean the data, and then you analyze the data, data analyst. Before analyzing, you will present it in plots, right? because you have to see it in a good form. We don't want to see all these, tiny minor details of everything. Let's suppose if you are trying to see that which pizza is more popular, is the pizza with pineapple on top of it is more popular, or the pizza with uh you know pepperoni more popular. So you don't want to see the name of the person who bought it, or how many slices this person bought it, how much did they pay, or we don't want to see which place did we deliver it to. We don't want to see all those things. We just want to see how many number of counts has it been done, right? So in table form, it's very messy. So we will put it in plots, graphs. Plots are nothing but graphs. So it looks much more cleaner. This is called data visualization. And let me type it for you. Data visualization. That's data visualization. When we put the whole raw data, this is a raw data. You call it as raw data. Raw data, and it's in Excel format or something. In a company, there are a lot of people who are working. They are managers, they are marketing researchers and all those people. And then there is product team, right? Now they would not know how to look at the data. They would not know if is it doing good, is it doing bad. You are the one who will clean the data for them, who will make it more visualizing, more appealing to the eyes, so that they can understand it easily, right? So that is why one single data has so many job categories under it. There's a data scientist also. Data scientist will be the person who will analyze and then tell a story behind this. So he will tell a story that, okay, this is very high, this is low, what should we do, and all those things, right? So data visualization is what we are going to learn today. What are the different types of forms it can appear in? All right. Now, coming to graphs. I'll make different videos of how you can change Excel sheets into graphs, and I'll show you. We will use Jupyter Notebook to do all those things. But for today, it's more about you understanding how these things work. It's an introductory video for the whole data and data visualization. Coming to how you would interpret graphs. Okay, this is the work of a data analyst or a data scientist. They look at the graphs and then they tell what is going on. Okay. Now, of course, they dive much deeper into it, but as a normal person, as a beginner, what you can do is simple graphs. How do you check a graph is? You look at the title. What does the title say? How easy a math problem is, right? So what is this graph about? We're seeing that something related to math problem. Is it easy, difficult? That's the topic of our discussion. Then labels. What are labels? We are going to see what are the metrics, or what are we trying to see related to math problems. So we are trying to see the difficulty level, and we are trying to see the location. What is location? This is so funny. Math problem location. So difficulty and location. So we are trying to see, based on what location, how is a math problem difficult. Okay. Scale is this scale where you're measuring things. Both scales, this scale and this scale, both are scales. It can be an x-axis, it can be an y-axis, but it's more of a measurement. So in class homework test is definitely not a measurement. So our measurement is difficulty level. I'll tell you what is x and y axis. Let's say this is a graph, and the value, this, when the two lines meet, that is the 0 point. Okay, it's a zero. This is 0. It's a center point where both of them are meeting. Now, this is an x-axis. X is moving your values left and right. Y is moving your values up and down. This is why as you cross 0, go down, it will become y naught. And as you go to x, when you cross the cross the 0, it will become x naught. It's nothing but it's like 0, 1, 2, 3 number line, 4, 5 number line, and before that you have -1, -2, -3, which is the x naught. Okay, I know it's not such a cool or beautiful drawing, but yeah, that is what axis means. Scale is how are you measuring it. We are measuring it based on difficulty, and our scale is on either x or y. Which one? It's on y for this graph. Okay, now let's look at each bar. How easy is a math problem? Stupidly easy. Stupidly easy. Simple, easy, difficult, hard. What is this? So in the class, when you're with the teacher, it looks kind of simple, not easy you can say, but like not really simple, somewhere in between. Homework, when you're doing homework, it looks hard. It's like not even difficult, it's like hard. What is like it's hard to do. Then you refer back to your notes and you are able to solve it. In the test, you're like, what is this? Did we even learn this? Right? So this is how you interpret graphs. You look at the title, you look at the labels on the side, you look at the scale, and then you see it. Okay. Now, coming to the different types of graphs that we have. Bar graphs, the one that we saw just now, this is a bar graph. Like the name itself, they look like bars, right? Now, they're rectangular bars. If you look in 3D, it's cuboid. Okay. And how do you read them is the taller the bar, the larger the amount is, right? If I'll show you how it works. The tallest bar means most data was captured for that value. The shortest bar means very less data was captured for that value. That's why it's so short. Okay. Now, let me give you an example. Whom do you text message? Okay. Now, that's the title. We look at the title, then we look at the categories. We have percentage and people, right? What is the label? Percentage and people. What are the categories in people? Parents, grandparents, sibling, girlfriend, boyfriend, children, friends, classmates, project mates, professors, teachers, others. Of course, I knew this professors, teachers, no one does it, no one messages. And then you have percentage, 0 to 100 percentage. Okay, that's the scale. These are the categories, these are the scale. So one side you will have scale, one side you will have categories. So we said the longest is the most done, the most data is captured there. So of course, you text your friends the most. You're always texting your friends. You're sharing memes or you're sharing the reels over Instagram or you're always texting them. Then what's the next thing? What's the next thing? Classmate and projects mate. Now this is such a professional messaging. I've seen students emailing each other for projects, right? So they are in contact just to discuss projects or their classmates, right? Because then there's some tea going on and you always have to discuss about it. Next, of course, this one and siblings. Okay. That's I don't know siblings. I don't know if this data is correct with siblings. Is it true? I'm not sure. Or am I weird? I don't do that much. Okay. And then come parents. Parents is like they will text you, and if you don't reply, you are not going to enter the house. Grandparents, of course, you don't text them because they don't understand. Children, they don't understand again. Professors and teachers, nobody would text them. Nobody would text them. Even if they ask you to submit things on email, you will just forget it, or I don't know what happens. Others. So what we did just now is the job of a data scientist who looks at a graph and then who tells you a story behind it, who looks and interprets what's going on, what's the whole story, what's the scenario, right? You can have double, triple bars. Like you can have more than one bar, one beside the other. You're like, What do you mean? This doesn't make sense, right? I'll tell you. This is how it looks like. Okay. When you have more than two categories to compare in one single category, that's when you have these double bars or more than double bars. What does this mean is I'll give you a very simple example. Let's say if I ask you what's your favorite chocolate, what would you say? For me, it's dark chocolate. I would say dark chocolate. Right? Someone can say normal chocolate because dark chocolate is it's strong. So you can say normal chocolate or milk chocolate, or you can say white chocolate. Right? It differs. But then again, even in this category, in these categories, you will have more categories. Let's say brands. Like if I ask you what chocolate do you like, some people might end up answering it by saying the brand of the chocolate. Like you might end up saying Galaxy chocolate or the Mars chocolate, right? Things like that, or Nutella. Okay. So it can be divided into many, many ranges. So when you have more than one category and it can be split into multiple categories, that's when you have more than one graph. Here, same thing, you are going to, there's no title, which is weird. Always have a title to your graph. Engagement by memes. So this is, wait, is this, are you, am I, there's no, okay. Engagement by memes. So I'm guessing this is about teaching methods. The title is teaching methods. Let me write it. What if they don't write? I can write. Teaching methods is the title of our graph. Engagement by memes. Pretty solid. Going solid. Okay. Now, how do we see it's solid? All of them are showing the same, almost closer graphs, right? But look at the thing. Strongly agree, agree, neutral, disagree, strongly disagree. It says strongly agree. That means when a teacher uses memes to teach you, they engage more. This is a very solid teaching method. Teaching by learning, if you teach those things to others, you will learn it. It's actually a method people use. I used to use that in school and college. I used to teach topics to my friends, and then that's how I would learn it. Okay. So teaching, learning, understanding of the course when you are actually listening to your professors, understanding it. So agree. They also said neutral. It's a neutral thing. So mostly it's agree neutral. Topic diversion by extensive. It means you are researching about it and stuff. Agreed. And they are strongly agreeing with this. Coming to combination of teaching, many methods of teaching, research and stuff. So it's like that. It's where you're comparing two or more categories. A bar graph shows the number of students who prefer different fruits. I do not. Okay. Fruits in your class. Apples. I don't like apples. Okay. Fruits in your class. Apples 15 students, bananas 10 students, oranges 10 students. How would a bar graph like that look? I want you to actually draw it. And of course, so let's use colors. Red flags. Kidding. 15. So this is how the bar graph would look like. Bananas 10. So 15, if I divide it in three parts, comes here. Bananas 10. Oranges 12. A bit higher than, okay, ignore this part. A bit higher than bananas, but still less than apples. Okay, this is your graph. This is how it should look like, and you would mention numbers here. 5, 10, 15, 20, like that. And this is apples, bananas, oranges. Mention the label fruits and mention number of students here on the side. Do not mind my handwriting. I'm just using my touchpad. And of course, the title. Okay. So that's how you would make a graph. And you can see clearly apples are the most popular fruit. Next comes the oranges and then the bananas. This I did it for you because it's the first solution problem. So I wanted to show you how you can solve it. The second one, I want you to solve it by yourself. I don't know. I would not explain. A double bar graph shows the number of goals scored by two football teams. So team A, team B. You know the two categories now. Two main categories, team A, team B. Over four matches. So we had matches. Match one, match two, match three, match four. How much goals did they do? Two, three, two, four, two, three, three, five, four. How would that graph look like? Do that and analyze. Do not look, oh my God, let me hide this. Do not look at the solution. You would do it, pause the video, do this, check how's your graph looking like, and then look at the answer and see if you have done it correctly. Two line graphs as the name. So all the graphs and plots are given their name because of how they look like. Line graphs look like lines, which is why they are given this name. Now, they are lines because they track how trends move in time. Generally, that's what they do. You would see different types of line graphs. They are shapes of different line graphs. A line graph, a normal line graph would look like this, like can be up, down, anything, any weird movement, can even drop. Curve graphs, even in curves graph, there are a lot of curves graph. There's like a whole list. There's name, exponential graph, and all those things. We will not dive that deep into it for today. Let's keep it uh beginner friendly. So curve graphs is where you can see some sort of a curve. It can be like this, or it can be like this, or it can be like this. Anything, but it's like a curve. It's not so harsh like these points. Okay. So that's the two different types of line graphs. And yeah, curve graph are more complex. Can you tell me why? Because their values are very close to each other, which makes it a curve. When the values are not close to each other, they are not related, they're very diverse. That's when they become very far away from each other. But it becomes curve only when it's more complex. It's close to each other. Only then it can form a curve. Or else it wouldn't form a curve. Right? If it is like this, very far from each other, it wouldn't form a curve. It would form like a triangle or something. If they are close, only then it forms a curve. So line graphs are like this, and it is used for very complex data, like a huge data which has a lot of values in it. Daily temperature changes, you would see, stock market is one of the most famous for line graphs. You can also see bar graphs in stock. So bar graph and line graph are really popular. They are candlesticks, so I think that's what you see. I'm not sure. So yeah, that's the common use of these things. Let's solve one line graph. Smartness versus time. So how smart are you with time? That's the title. And I've mastered it, I've got it. Good enough sounds familiar. Heard of it? No idea. Before exam, during the exam. Okay, it should be smartness versus exam time. So before the exam, of course, everyone would be like, I've mastered it. I know this, I've cracked it. Then during the exam, when you get the question paper, everything, you're like, good enough. You just started it and you're writing it. 1 minute after the exam, you feel so proud because you've just done it. You're done with the exam. You're like the sense of achievement, the feeling of accomplishment. Then 1 week after the exam, you somehow start forgetting things, right? You will forget what all things you've got. And then 1 week into summer break, that's it. You have no idea of what you had learned in the previous year. Nothing. Everything is gone. Even you would need revision, or you would be like, I'm in no mood to revise. Okay, that's a line graph. I want you to solve a problem for the line graph. A line graph shows the daily temperature. Yeah, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Their temperatures very close to each other. So, what type of a graph you would end up getting? Tell me. Is it a line graph? Is it a curve graph? And make it, and then tell me what's the highest, what's the lowest, and did you find any peak drop anywhere? So, yeah, do that. Put it in a comment section. All right. Coming to pie chart, this looks so yummy. Wow, okay. And I'm fasting. Okay. Pie charts, the name, it's it's derived from pie. I mean, they could have said pizza charts too, right? That should be a thing. Is it because were pie was made before pizzas or something? I'm not sure. So they are named as pie charts. I don't know why they are not named as pizza charts. Serves the same purpose of splitting it into pieces, and they're circle. Okay. Anyways, let's focus. Pie charts are named because of the pie, how pie is cut, because it's a circle, right? You don't cut it in like um you don't cut it how you cut normal fruits and vegetables. You cut it like the specific type. This, oh, I had the color of pie. You cut it like this. Okay, from the center. You make diagonal lines from all across the circle, circumference. Okay, so which is why it looks like this. And that's a pie chart. Let's look at a real pie chart. Things I do when my internet connection is being slow. Get offline. Stop loading one of the pages. Start a game of solitaire. Oh, I don't play that. Open another tab and attempt to load something else in addition to the already slow pages. So yes, pie chart is, you would also have numbers on it. You can have it like this. Okay. Why do I end up having the same color always? Camouflaging. Better. You can think this is 85%. And this is 10%. Oh my God. Okay, this is black. 10%. And then this is 2.5, 2.5, right? So that's how your pie chart works. You would see percentages written on it. Sometimes you would not see it. Okay, it's like a circle split in different pieces. I want you to solve the problem of a pie chart showing favorite colors of 100 students. Red, 50 students or 50%. And then blue. Okay, you're going to now make a circle and try to divide it. So 50, let me help you out in this. Think I can make a circle like this. 50 students are red. So what do you mean by 50 students are red? You are going to split it in half, color this entire portion red. Then 30 are blue, 20 is green. So how would you do? Will you do it in half? No, right? You would have a little more. This is 50, this is 25, 25. So we need 30 and 20, right? So this is the one. I'm showing you how to divide it. That's how you do it. So now let's use good colors. It says blue and green. Let's use blue. So blue is 30%. It's not half, it's a little up more than half if you observe. It's like this, it's like this. And green is 20%. So something like this. All right. Now I'm gonna give you a target. Make a pie graph for the books read by 5 students: Alice, Ben, Chloe, David, Emily. How many books they've read? Make a pie chart, divide it, And so you would have to count the total number of books, make it into a percentage, and then see how much percentage each of them are getting aligned. That's how you would make a pie chart, right? Then see who has read the most books, who has read the fewest books, what is the total number of books, and how much is the difference between the highest and lowest number of books. So I want you to solve these questions. Put it in the comment section, right? Yeah, I need the data. You are not skipping it. You are not skipping. I'm telling you, you're not skipping the questions and then you're like, oh no, I got this. I understand. Actually do it. Actually solve it. I need to see the comments. So this is the solution. Stop. Stop. If you have not done it, if you have not worked on the problem, pause the video. Do not look at the solution. Do not cheat like people cheat in their relationships. Don't do that. Pause the video right here. Okay, if once you're done, now let's look at the solution. Did you just lie to me? Did you just lie to me saying you did it, but you didn't do it, and you just wanted to see the next part of the video? I said pause. Okay, so our good people, honest, loyal people who have actually worked on the problem. Here's the solution. 10 is the most books read, and who read it? Of course, our dearest Chloe has read the most books. Fewest books, Ben. Oh, Ben, dear. And 36 books were read in total, which is such a good number. I really wish students were like this. Five is the difference between the highest and the lowest. So, oh, Chloe read five more books than Ben. Wow, that's double, almost double work. Okay, that's how you would make the graph. Pie graph, you would see Ben's and Chloe's. Chloe's should be almost twice the size of Ben. Okay. Perfect. So now you have mastered data. You've not mastered it, but you now know things. You now know what data is. How do you do graphs? How do you make them? How do you compare them? How can you make a story out of it? How do you interpret? Like interpreting is like trying to see what's happening. Who has the most things? Who has the least things? Or what's the data trying to do? You've understood pie charts as a whole. That's correct, right? Keep practicing. Look around you in newspapers and everywhere. When you see a bunch of data for each category, try to put it out on a paper. Choose one of the categories, either bar graph, line, or pie chart. Make it, right? You can make it online on a tool, either in Microsoft or Word or something, or you can do it even in Google. I think you will be able to make it, or you can do it on a pen and paper also, anything, right? So data is everywhere. Now you know how to make stories out of it, like how I made stories out of it. What gives people feelings of power, money, status to win the class Kahoot? Yeah, so I know right now whoever got all the answers correct for their charts that we did, shout out to them. Really good job work. Now, the last part, the end part of our video, the main question is, should we actually follow the data or your instincts? Yeah, tell me. Put it in the comment section. I'll like, should you follow data in the sense, should you go and buy Labubu, or should you follow your instinct that it's some cursed toy, you should not buy it, or it's not only about that, it's about a lot of things. Even in real life, even in relationships, even in a lot of different areas. Should you follow the data or your instincts? Put down in the comment section, okay? Till then, see ya, guys. Bye-bye.